So this is question number 5, which also comes from the Northern Hemisphere 2022. A spring with a weight attached is suspended from a stand. The base of the weight is 40 centimetres above the bench. So there it is, 40 centimetres above the bench. The spring is released and moves vertically up and down. So it's moving up and down like this, but obviously it will move less and less and less and less as it's released. So the spring is actually going up and down vertically, but if we graph its height against time, we get this shape to it. Okay, so that's the rule for h, which is the height against time. And this is an exponential times a cos graph plus 20. So here's the middle, which is 20 going up and down, up and down. Okay. The dashed curve B1 lies above the graph and B2 lies below the graph. Both B1 and B2 bound the height of the graph. The dash curve B1 has that equation, the dash curve B2 has what equation? Okay, so that is the curve that determines the maximum heights as it bounces back up and the minimum heights as it bounces back up. And we have some symmetry happening here. Therefore, to get from B1 to B2, I would like to reflect over the y-axis. So that will take my 40 down to negative 40. Then I need to plus it up. So I'm going to reflect over the y-axis, then move up 40. So let's get some space here. Reflect over the x-axis, then translate up 40. So this rule would become reflect over the x-axis, so minus y equals 20e to the minus t on 5 plus 20. So y equals minus 20e to the minus t on 5 plus 20. And when we move up 40 units, y minus 40, therefore that's a minus, and that's a minus, that's a plus. So I'm looking for B2 equals minus 20e to the minus t on 5 plus 20. Now to find the average value of the height. So this is the height. So the average value of the height for the first 10 is the average value rule, which will be 1 on 10 minus 0, integral from 0 to 10 of h of t dt. And that should give me the average height. So on my calculator, that's going to be 1 divided by 10 integral from 0 to 10 of the function, which is, if I move this over a little bit, so I've typed that in, and that gives me an answer of this, which in decimal form is 20.008752, 2 decimal places, equals 20.01 centimetres is going to be the average height. Write down a rule for the derivative. Just keep in mind that if they're asking you to write down the rule for the derivative, you're going to use it. Otherwise, why will they get you to write it down? Okay, so I'm just going to use my calculator to take the derivative. So that's my function. And if I take the derivative, interactive calculation derivative, make sure you write it all correctly. So h dash of t is going to equal minus 4 cos 2xt plus 40 sine 2xt. Find the time in seconds and the height of the surface. So I want t and h of t. Find the point of the maximum positive rate of change. So I want the maximum h dash of t over the first 10 seconds. Write your answer as a coordinate of the pair. Okay, so I need to find where the maximum positive rate of change is. So I'd like to graph h dash of t and find where it's positive maximum is. So if I open up a graphing window, I'm going from 0 to 10. If I take my derivative, I'm in radians, that's good, drag and drop. And maybe I go up to, what's my highest point? Well, maybe I'll use zoom auto. So from 0 to 10, so -1 through to 11. And OK, then zoom auto. And I'm looking for the first time there is a maximum positive. So I'm looking for this point here. So it starts and goes down and looks like this. I'm looking for this time. So I go analysis, G-solve max, and that time is 0.739. So 0.73987. So if I take that, so that's my X time. So keyboard math3 given X equals. And I need to find the height at that time because it's asking for height. So my answer is going to be 0.73987. And if I grab this expression, this is my height at time t. Lost my given, and I'll put my given there. And that answer is 18.903. And we want to give this to one decimal place. So 0.7 and 18.9 is the time and the maximum height. And determine the total distance travelled. Okay, so if I've got a graph of d dash of t, that is dh dt against t, the area under the curve will be the distance travelled. So now I'm looking at the graph of the derivative, and I want to know the area of the derivative for the first 2 seconds. So if I get my graph and I change this from 0, let's do negative that to 2.1. I'm looking for that plus this plus this plus this. And I could do analysis, G-solve integral from the roots, except the first one, come across and accept the fourth one, which is 1.99 or 2, except that total is 132.048. So A, B, C, D, distance travelled will be the integral from 0 to 2 of h dash of t, but the positive of it, dt, or it's going to equal 132.903. It's worth 2 marks. So this is enough to get the method mark, which is going to be 132 centimetres in distance.